Solve the equations 2 sine squared theta minus 3 sine theta plus 1 equals 0. We recognize that this is a quadratic equation. To make it easy, we will let t be sine theta only. Then t squared is sine squared theta. And this equation is now 2t squared minus 3t plus 1 equals 0. We will solve for t, but eventually we will need to find theta. This is a quadratic equation, so we will attempt to solve it using factoring. 2t times t. Since the product of the constant terms is 1, we will use -1, -1 to see what happened. We use negative because of the negative 3t here. This is our guess. We can check by multiplying this in. 2t times t is 2t squared. 2t times -1 is -2t. -1 times t is another -t, so -3t total. -1 times -1 is +1s. What that means is that we factored it correctly. This is a zero product, so we will end up with 2t minus 1 equals 0, or t minus 1 equals 0. This will give us t equals 1/2, or t equals 1. Now we solve the quadratic equations, but this is not the solution, because the solution should be in theta. We will perform a back substitution. Remember that t is sine of theta. And so we first set sine of theta equals 1/2 and solve theta. For the second t, we set sine of theta equals 1 and solve for t. If sine of theta equals 1/2, then theta equals, we will use the unit circle, but we only look at angle from 0 to 2 pi only. Sine of theta equals 1/2. We use the line y equals 1/2 because sine of theta is the y coordinate on the unit circle. And we see that there are two angles between 0 to 2 pi that will give us sine of theta equals 1/2. And those two angles are pi over 6 and 5 pi over 6. Sine of theta equals 1 only when theta equals pi over 2. And so we have 3 solutions, and all of these 3 solutions are in the interval 0 to 2 pi. We summarize the solution here in increasing order. Theta equals pi over 6, pi over 2, and 5 pi over 6.